Hi guys, welcome back to our mathematics tutorial. My name is Peter C. Douglas Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's video, I will be discussing differential equations. So under differential equations, I'll be looking at formation of differential equation, and that's also called elimination of arbitrary constants. So we have a problem. We previously did like 5 problems in our previous lessons. So we want to do the 6th problem now. We said we should find the differential equation of the family of curves given the equation y equals to a cos of x squared plus b sine of x squared. So it is very easy. Please don't panic. It's very easy. So the first thing we need to identify is how many arbitrary constants do we have within the equation. So from the equation, we notice that we have 2 arbitrary constants. So the rule says the number of arbitrary constants determines the number of times you are to differentiate. So since we have 2 arbitrary constants, it means that we must differentiate twice. If we had 3 arbitrary constants, we would have differentiated 3 times. If we have 1 arbitrary constant, we will just differentiate once. Hope you get that. The next thing is that after you have differentiated the required number of times, then you must design means. You know, sometimes it ends in simultaneous equations. Sometimes you can try to use matrices. But whatever way you think you can eliminate the arbitrary constants, do it very carefully. So in this problem, we will use simultaneous equation to eliminate the arbitrary constant. So let's get started. So we write the equation y equals a cos of x squared plus b sine of x squared. So we get the first derivative, y prime equals a, which is a constant, we hold onto it, and differentiate cos. Derivative of cos is minus sine of x squared times the derivative of the angle. So the derivative of x squared is just 2x. So we're done with the first one, we'll go to the next one. Plus, we hold on to b and differentiate sine of x squared. So it gives us cos of the same angle x squared times the derivative of the angle, which is just 2x. Now, we can simplify it further. Thereby, so let's put it, let's just put it right there. So we have y prime equals, so if we multiply, you have negative 2ax sine of x squared, and the next area you have a positive 2bx cos of x squared. So we call this equation number 2, and I'll call this equation number 1. So there's equation number 1, there's equation number 2. So from equation number 2, we can find our y prime. So we hold on to 2a minus 2a, and then we differentiate x sine of x squared. So since we have 2 trigonometric, let's say 2 functions, a linear function or a polynomial function and a trigonometric function, you must hold the first function, x, or the first factor, x, and differentiate the next factor, which is sine of x squared. So the derivative of sine of x squared is cos of x squared times the derivative of this angle, which is now just 2x. And then we say plus, we hold now sine of x squared and differentiate x, which will just give us positive 1. Close parenthesis, plus 2b, we hold on to 2b, and we differentiate x cos of x. So we hold x and differentiate cos. So it gives us minus sine of x squared times the derivative of x squared, which is now 2x, plus we hold sine of, let's say cos of x squared, and we differentiate x, we just get 1. So we can multiply y prime prime equals, so let's be very, very careful before you miss some of the signs, or you miss, you miss some of the constant terms, or just something else. Just be very careful, So we have 2a times x times 2x. So 2 times 2, this is 4a, x times x is x squared. Then cos of x squared. If we know the first one, move to the second. Plus, so it's not plus again, it's minus because of this minus. So it's minus 2a sine of x squared. Okay, so we move to the next. You have 2 times 2b times x times 2x times this negative, so it's negative. 2 times 2 is 4b, x times x is x squared, and then sine of x squared. Move to the last one, 2b cos of x squared. Okay, but from this equation, you clearly see that equation 1 can come out of this equation 3. So let's look there. Here we have cos of x squared, and here we have sine of x squared. Here we have sine of x squared, sine of x squared. Here we also have, okay, so here we have a and b. So sine is carrying b. So we don't have anything to do with this. Let's look at this one. Okay, so this is sine of x squared. A b is attached to it. A b is attached. A is attached to this one. Cos of x squared. 4x squared. 4x squared. Negative 4x squared. Negative 4x squared. So if we clearly see this expression, we notice that we can group the first term and the third term. Then we just rewrite the last, let's say the second and the last term, because it has no important role for now, in terms of some simplification. So we just hold on to it. So y prime prime equals, so if we factor out minus 4x squared, we will be left with negative times negative is positive, so it's a cos of x squared, which is a cos of x squared, plus, because negative times negative is positive, b sine of x squared. So what do you observe? You see this one? So this entire portion now is x. So it means everything in here is just, let's say this is y. So this whole portion now is just y. So you have y prime prime equals to minus 4x squared. So this whole thing is y. So we just say y. So this minus 2a sine of x squared. Just rewrite it. Plus 2b cos of x squared. And then we rewrite the same thing down here. Minus 2a sine of x squared. Be very careful before you miss out on something. 2b cos of x squared. So we call this equation equation number 4. Okay. So we got equation 1, we got equation 2, we got equation 3, and we got equation 4. So now the next thing we need to do, we need to use equation 2 and equation 4 to solve a system of linear equation. So we can simultaneously solve the system. Not linear equation now, but we can use simultaneous equation method to be able to solve for the constant in these two equations. So now we have y prime. So it's y prime equals minus 2. So we just adjust it small. So it's y prime equals minus 2 ax sine of x squared plus 2bx cos of x squared. And then y prime prime is minus 4x squared y. So the minus 4x squared y can just be placed, one side, so that we have similar expression under each other. So the next one will be 2a sine of x squared plus 2b cos of x squared. Today just y prime prime equals to this. So I can just push this thing behind of it, y prime equals, so this position I can put 0. Now we notice that equation 4, this equation, and equation 2 has some similarities. 2ax sine of x squared, 2a sine of x squared. So the only thing that is missing here is some x. Likewise with this, some x is missing right here. Some x and some x. So also, if this sign is positive, it means this expression and this expression can go out if there is x right here. If this sign is negative, it means this expression can, these two expressions can go out if there is let's say a variable x right here. So what we can do is that we can just multiply this thing by minus x. Simple. So if minus x is placed here now, we must multiply this minus x by every term. So it will be minus x y prime prime. So let's write the first one. Let's write the first equation. Y prime equals 0 minus 2ax sine of x squared plus 2bx cos of x squared. And then now we have y prime prime. So this time this is minus x, y prime prime equals, negative times negative is positive, so it's 4x. Now x squared times x is x cubed, y minus, this time this is 2ax sine of x squared minus, so this will be plus because of the negative sign, and then this and this now will be minus 2bx cos of x squared. So we draw our line and simplify. So we know that this cancel this one, this carry this one out. So we just left with y prime equals, so this is just 0, right? So we adding them now, we adding this equation and this equation. So it's y prime plus negative x y prime prime equals, we add this and this, so it's just 4x cubed y. So we can decide to send everything on one side of the equation. You have y prime minus x y prime prime minus 4x cubed y. So since we want this y prime prime to be the first term, but it has a negative sign, we can multiply this whole thing by minus 1. So therefore you will have minus y prime plus x y prime prime plus 4x cubed y equals to 0. So finally we will have x y prime minus y prime plus 4x cubed y equals to 0. So there's the differential equation. Or you can use dy by dx. So since the second order, we have the 2y by the dx squared minus dy by dx plus 4x cubed y equals to 0. So this is the differential equation for this solution, which we considered as the family of curve. So this was the solution that was derived when this differential equation was given. So in subsequent videos, we will teach you how to derive or how to solve this differential equation to arrive at that particular solution. So I want to say thanks for watching, and please follow our YouTube channel, and also please subscribe to our channel. See you in our next video.